Today we learned something about perpendicular lines. We've already learned something about angles. So let's start thinking about angles, right? So let me pull out a protractor. So here's my protractor, and let's see. What I'm going to do is I'm going to have a start and an end. So maybe I'm going to remind you, here's the starting angle. So this is the starting line, this is my starting direction, and here's my ending direction, right? So now what I can do is I can pull my protractor in and see what angle am I measuring. So hope this is about right, although so I have to center it right here. So I'm trying to center it, align it. It's approximately aligned, and you can see that the angle between the starting and the ending line here is 90 degrees. Okay, so that's what I mean by perpendicular lines. Now, there are different ways that you can check for perpendicularity. Maybe you can even get a set square. So let me show you a set square. So this is called a set square. So first let me get rid of this protractor and show you the set square. So the set square is really cool because it only has a 90-degree angle, and you can see that when I put the set square right over here, I'm trying to align it. So you can see that the two lines almost, I'm not doing a great job, but I'm trying to align it approximately here. You see? So now you can see that the line right over here, and then you can go and have the line right over here. These two lines are at 90 degrees angle. Okay, so the set square can also be used to either draw or check whether two lines are perpendicular to each other. By perpendicular, I mean whether they're at 90 degrees to each other. Okay, so let me get rid of the set square for now, and so here's the set square. Let me get rid of these yellow lines also. Okay, so this angle is 90 degrees. But note that you can see that if these two lines are at 90 degrees, all other lines are also at 90 degrees. So it's very easy to use a protractor to check that this angle is 90 degrees also. And this angle you can draw, and remember you can go either way. So I'll just to make sure this angle is also 90 degrees. The only difference is that this angle is 90 degrees clockwise, so I can call it clockwise. And so this is how the clock moves. The clock hands move in this direction, and this is called anti-clockwise. So this would be anti-clockwise, which is against how the clock hands move. So you can check the clock and see how do the clock hands move. And this angle is also 90 degrees. So all these angles are 90 degrees. Okay, because remember, we have a 360-degree angle. We have, if I remind you, in a circle, we have, so if you start from here and you're turning, so as you turn, the total angles, remember, is 360 degree. So now we have 490s, and 490s are 360. You can check the total angle is 360 degrees. Okay, so I forgot to draw the arrow. Now, in any case, now please, I just want to remind you that you have seen these perpendicular lines many times in your life. So for example, let me draw a symbol, and maybe you'll so here's a symbol that you might you might remember. So here's the symbol, T. So here's the English symbol T, and you can see that this angle right over here is 90 degrees, and this angle right over here is also 90 degrees, right? Let's look at maybe the English word H. So here's H. I'm going to draw H right over here. Oh, so I need a line. So here's a line. Okay, so now I'm going to draw H. So here's an H, and here's another line H, and then I'm going to draw a line right in the middle, And I hope you can see that this angle right over here is going to be 90 degrees, and this angle is 90 degrees, and obviously this angle is 90 degrees. And just to make sure, I think the font was a bit short. This angle was also 90 degrees, and this angle was also 90 degrees. So you have seen the T's and the H's, they're lines which are intersecting at 90-degree angles. So you have had some experience with perpendicular